You may want to move closer to the microphone, please.
Okay. Good afternoon, everyone. My name is Camilo Guerrero, and today I will talk about the atomic force microscopy, AFM. So the atomic force microscopy is a device. It's basically a high-resolution microscope, which help us to get the force between two surfaces and also high-resolution images of a surface. So it was invented in 1986 by Guerrero, who, by the way, got the Nobel Prize because of this invention. And the setup is composed first by a drive, which is from here, and basically it holds the samples. And then by a system of strain gauges, it helps us to move the sample in the X, Y, and Z direction. And then we have here the beam, which has a tip at the end. And depending on the mode that you are working with, you can get the surface topography based on the deflection of the beam and also on the vibration of it. Then the beam is connected to this probe, which constrains the vertical displacement. And then we have here in phi a piezo crystal, which induces the vibration when we apply an electrical current. Here in 6, we have the laser, which basically emits the light. It bounces on the beam, and then it gets reflected here in the photodetector. So depending on the vertical deformation of the beam, we may have a different pattern. So now we collect our wave, our signal, and then we process it in a computer, and then we get the final surface profile of our sample. So as I said before, we may have two different ways of process to run this test. So on the left-hand side, you have the contact methodology. In this case, the tip is always in contact with our sample, which means that the surface topography will be a function of the deflection of the beam. So the disadvantages of this methodology is that we induce the damage of the tip and also in our sample. So that's why they reported another way to run this test, which is the intermittent contact. And by doing this, now the tip is oscillating in the vertical direction, which means that the topography will be a function of the oscillation amplitude. So by doing this, now the number of contacts between the tip and the sample will be lower. So what we can measure here is first, as I said, the surface topography by selecting either the contact mode or the intermittent contact mode. But also the AFM can work as a force spectroscopy. So in this case, we can measure the force between two surfaces. I will come back to this later on. Then we have the tip, which is basically the most sensitive part of the AFM. So in this case, you can see these pictures, which basically show how the tip was damaged after using the same tip many times. So this is unavoidable, but in general, replacing the tip is very costly. So we want to preserve it as long as possible. In terms of sample preparation, the maximum weight is up to 300 grams. The sample size is constrained by the diameter of the drive, up to 10 centimeters, and the height up to 1.5 centimeters. We also may include another variable, which is the temperature. So we may run the test from room temperature to about 150 Celsius degrees. So in terms of applications, we have that first regarding surface topography. I found many nice papers. They are basically driven by people's curiosity. So in this case here, you have this is a surface image of a sodium chloride molecule. It was the first one reported in 1990. But also we may track bacterial interaction with surfaces, as in this case, adhesion between cells and a mica surface after being immersed with saline water. Also, we can assess the contact forces. This will depend on the height of the beam and also where we are working with attraction or repulsion forces. So in this case, this paper, they publish friction at the atomic scale. So they assess the force that is needed to move an atom along a metallic surface. So in general numbers, we have that the resolution in X, Y, and Z direction is less than 1 nanometer. We have in some cases that this device may have included a camera, so the resolution of the camera may go lower than a micrometer. Here we have the range for the force on the surface, and the precision will be a function of the state of the tip. Here's the list of some manufacturers, and in general, the cost will range between 20 to 40,000 US dollars, where we want to get the computer with the software on the stage, and the AFM percent it varies between 34 to 100 US dollars. So this is the list of the references that I use. Thank you very much for your attention.